Hello everyone, myself Ashit Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here unit number 2, Embedded Engineering User Interface. So in that content we are going to discuss here PCB layout, testing and debugging. So first of all, we look at the learning objective for this session. So first learning objective is to know the PCB layout, that is printed circuit board layout. Then second learning objective is to understand the PCB testing and debugging. So after this session, some learning outcome is there. So first learning outcome is the student will able to explain the PCB, that is printed circuit board layout. After that, the second learning outcome is the student will able to aware about benefits of PCB testing and debugging. So first of all, we look at the printed circuit board. The printed circuit board or PCB used to mechanically support and electrically connect electronic components using conductive pathways, tracks or signal traces etched from copper sheets and laminated on non-conductive substrate. So this is the main function of PCB. So the PCB are the backbone of electrical devices. They are non-conductive board that can hold all electronic components through a circuit and embossed over it. The PCB are built to last for a wide range of industrial, commercial, and domestic applications. They can be customized to any specification to user requirements. So this is regarding the PCB. So actually the PCB is usually a flat laminated composite made up from non-conductive substrate and with layers of copper circuitry, and they can be simple as one as two layers of copper or high density applications which can be where they have 50 layers or more will be occupied. Also the PCB in humans have find increased rates of the liver cancer, gallbladder cancer, biliary trust. So that type of link to be calculated from this PCB. So the PCB is more applications in healthcare. So this PCB are also known as to cause a variety of types of cancers in rat, mice and other study animals. So this PCB the used to save a lot of space along with reducing the overall board weight. The flexible PCBs help in decreasing the board size, which makes it ideal for various applications for the signal tracing. So this is the advantages of PCB. Now we will discuss regarding the PCB components. The PCB components are made up of variety of complex electrical elements including resistor, capacitor, diodes, transistors and fuses. So this can be identifying the PCB board, and it can be create on that functions with a different age. So here the PCB is a thin board made up of fiberglass, composite epoxy or other laminate materials, and conductive pathways over the etched printed onto board. And the PCB such as transistor, resistor and integrated circuits is there. Then PCB is used to uh, mechanically support as well as electrically connect and electronic components using conductive pathways. So therefore there are different components. Then your servo motor is there, tail motor is there, main motor is there, power supply is there, then LED light is there. So these are the components which are lie on the PCB. Now we'll discuss regarding the types of PCB. So there are three types. So one is the single sided, second is a double sided, third is multi-layered. So in first, or you can say single sided, the base material clad with copper on one side. So this is the one scenario for single sided. In double sided, the assembly encompasses a base material with a common, or you can say copper on its both sides. In multi-layered, it can encompasses with several layers of substrates. Each layer is separated by an insulation. So this is regarding the types of PCB. Now we move for the PCB parts. So the assembly consisting with the following parts. So the components is actual devices in a board, and the PCB components can be categorized as active and passive components. So first of all, we discuss regarding the active components. So first is a diode. It allows the current to flow in one direction. Second is a transistor. It can amplifies and switches electrical power and electrical signals. That is the function of transistor. Then ICs. Then IC means integrated circuits. It is responsible for several signal conditioning functions. The next part is for passive components. So it includes for capacitor, and it stores and discharges electrically. So this is the benefit of capacitor. Then resistor, it limits the power of electrical current. And then inductor, it is responsible for creating a magnetic field. So this is the functions, and these are the components is mounted on the PCB. So in connection with this, the pads where the components are connected, or you can say soldered it, and it can traces the connects pad together, and which is responsible for making a electrical connection between the layers of PCB. So in the top metal layer, it can assemble the fewer traces in the top side, and in the bottom side, the many of the traces is there as compared to top of metal layer. Then steps involved in a PCB. So first of all, we discuss regarding this the part research and selection. Then next is a schematic capture and simulation. Then third one is the board layout, or you can say PCB layout. And last one is the fabrication. So in PCB layout is high level engineering tool for board design, and can featuring the smart manual routing and differential signals shape based auto router that can be verified and can preview in a 3D exported for mechanical CAD modeling. So it can create a schematic for the PCB layout, then create a setup for PCB, link the schematic to PCB, define the board size and layer sec, then place the components, insert the drills and route the traces, and finally is the component. So this is the simply connected the high speed PCB design. So here the signal starts to be affected by the physical characteristics of the circuit board, like the packaging, layer stack up, interconnections. So this is regarding the board layout. And last point for this is the step involved for the PCB is the fabrication. So there are different fabrication is method available with us. So first we will discuss regarding the PCB laminated manufacturing. So in that content we know that the prepreg cutting is there. After that it should be lamination of the lab is there, and after lamination it can presses up to 370 degree Fahrenheit. Then copper cladding system is there, and after that it can trims and cue the sizes, and lastly that is packages and shipping. So this is the procedure for PCB laminated manufacturing. So it can clears the all the from cutting section to the shipping section. So this is regarding the PCB laminated manufacturing. The next is a PCB fabrication. So already we discussed regarding the PCB fabrication. So first point is schematic preparation. Second point is layout preparation. Third point is etching process. The next drilling, solder masking, silk screen, electrical testing. So this is the PCB fabrications. Now we will discuss regarding the next point, that is debugging circuits. So whenever the complicated circuit is fixed built is not uncommon for the circuit. So in non-functional or non-working, or can say wiring connections or errors, faulty parts, then incorrect equipment settings. So this is the debugging circuits. So the process of finding and correcting these problems is called as debugging. So there are two rules. So in first rule, make sure the debugging tools has working properly or correctly not. For example, test the whole motor on a battery, test the scope using the provided test signal. The next, for second rule, it can study the circuit diagram until you have at least general idea of functions of various parts and know enough about the components to be able to raise or can say devise a test to determine whether or not each part is functioning properly. So this is regarding the debugging circuits. So always remember that whenever the finding the corrections in the problems in a PCB, that is called as debugging circuits. Now we know that the PCB testing. So inspection and testing is ensure the high quality in the manufacturing of PCBs and electronic devices. Then manual visual inspection. So this has been replaced by AOI. So that is nothing but automated optical inspection, and AXI to catch the areas in components. So AXI is nothing but X-ray inspection. The next is the list. Then circuit and functional testing can check completed PCB quality. So in that functional testing, so to test a PCB functionality, a functional tester interfaces to the PCB via its edge connector and test probe point. So this is regarding the PCB testing. The next point is for in-circuit testing. So in-circuit testing, the equipment measures the each component. Uh, so in-circuit testing, it involves the each component to check that it correct or in place. During the ICT and electrical probe, test a populated PCB, checking for shorts, opens, resistance, capacitance, such a type of factors we can correctly made. So this is regarding the in-circuit testing. Now we will discuss regarding the PCB material options. So when it comes from the manufacturing parts, so there are several material options is available. So first is the substrate material, conductor materials, adhesive, protective coatings. So these are the material options is available with us. So first option is substrate material. So in that contain epoxy imprinted fiberglass. Second is polyester. Third is polyamide. So this is regarding the substrate material. Then second is the conductor material. So it can roll copper, foil, electro deposited copper. The next point is for adhesives. So polyamide adhesives, polyester adhesives, acrylic adhesives, epoxide that adhesives. So these are type of adhesives available with us. Then next, protective coating. So the polyamide adhesives, the cover lays polyester to polyamide is converted with a suitable adhesives. The next we discuss regarding the packages types. So PCB layout can be, there are the two ways it can differ. So that is surface mount. So PCB components are mounted directly onto the board through hole. So the component with lead are inserted through a mounting holes, the name through a hole. The next, there are different styles for the handling. So first is rigid. So that is solid construction. For flexible, that is flexible circuits. Rigid, then multi-circuit boards. Hybrid, and very small circuit can be integrated as part of larger circuit. So this is regarding the board style. Now we go for manufacturing and assembly types. So PCB manufacturing steps. So following are the steps involved in a PCB fabrication. Second, the base material preparation. Clean the laminate and cleaning the copper foil. The next step is cutting the base material. Post the cleaning process, cut the laminate to required should be done. Then generate the circuit pattern. The desired circuit patterns can be generated by screen printing or photo imaging. Then six is the each the circuit pattern. Each the copper terminate the or laminate the containing the circuit pattern. Drilling the holes, pads and wires. Then through the hole pads deposit the holes with a copper and must chemically plated. Then apply cover by protect the top and bottom side of the board by applying the suitable cover. The next cleaning, the clean flux distributes the left during the manufacturing process. Testing, this process includes the automated optical, we can say that the optical inspection, that is AOI, flying probe test, functional test. Then rework, the rework may be done as in the PCB. The next is component missing, component replacement, trace or repair, cut and jump. So these are the points related with manufacturing. Now we move for the applications of printed circuit board. So, so this is the distributed area where we can use this PCB. So first is communication, this is a major part, industrial control, power electronics, medical, then circuitry of security, then consuming, then computer, then aerospace, automotive, other. So these are the applications areas. So according to that, there some weightage is there. The medical, the pacemakers, imaging equipment, drug delivery systems, wireless controllers. So this is the way. The next is a military, then weapons guidance systems, communication system, GPS, then aircraft, missiles. Then next aerospace, the radar equipment, GPS, radio communications, systems control. So this will help to manufacturing. The next telecommunication, the base station handle units, the communication, satellite, wireless communication systems, signal conditioning systems, etc. Then automotive, that is electronic components. In case of electronic control module, the transmission controls, LCD display, comfort, that control units, air conditioning systems, music systems. So this is also applicable. Then manufacturing, the test equipment, electrical switches, then industrial or automation systems, then consumer applications, oven, TV, remote, then controllers, washing systems. So this is the application of PCB. So this is a typical application for PCB, that is printed circuit board. So first of all, we discussed regarding consumer electronics. Then in that, digital wristwatch, CD player, AM FM radio, alarm clock, television, then calculator, cellular telephone, home computer, handheld video games, remote control unit, that toys, etc. So in case of telecommunication, it is point to point, microwave, the transceivers, police, fire, rescues, digital network equipment, cell telephone, relay stations, automotive electronics, automatic ignition systems that controls the fuel air fixtures, then fuel injection, dash instrumentation, then radio and TV entertainment accessories. So this is the whole applications which is useful for automotive and as well as telecommunications, the customer electronics. So this is the application regarding the PCB. So this is the components of PCB. This is the typical PCB. So this is regarding the board styles, manufacturing steps, applications of PCB, and typical applications of PCB. Thank you. So in this lecture, we discuss regarding the testing, debugging, and the settings related with the PCB. Thank you.